Problem number 18, we have a point in Cartesian 0, 4, minus 1, and we have to find the unit vectors of the cylindrical coordinates. So I draw this point P0, which means x equal to 0 and y equal to 4 and z equal to minus 1. So it comes down to here, P. Now this is in cylindrical coordinates, so this is my vector, position vector, and for cylindrical coordinate I draw the unit vectors. I draw the z-axis, the z coordinate, which is minus 1, and the direction which is perpendicular to the z direction is the arrow, and AZ will be up. So I just delete this. So this is AZ in this, the coordinate, and A5 will be going in the, because this is my cylinder here, and A5 should be perpendicular. So this is my phi plane actually. So A5 will be going like this, or in this direction. This is A5. Take this here. So this is my A5. This is my point P. So as we can see from here that A rho is actually equal to A y, and A phi should be in the direction of negative AX, and AZ should be equal to AZ. So I can predict these values, but I can also find it by the unit vector uh, relations given in the formula sheets. So I can go to the unit vector. So A rho in terms of Cartesian is equal to cosine phi AX plus sine phi A phi, and A phi is equal to minus sine phi AX plus cosine phi A phi. Now phi is equal to tangent inverse y over x. So at this point P, phi is equal to 90 degrees. And we can also see from here, because this is my phi plane, so I can draw this is actually the scenario here. So this is my point, and this is the cylindrical surface here, this one. So this is my arrow vector. So the angle from x-axis to this plane is 90 degrees, and I can also from tan inverse. Now a rho, if we put 90 here, cosine, if we put 90 here in the cosine, so a rho will be equal to 0ax plus a y. So a rho will be equal to ay, and in the second relation a phi is equal to minus sine 90 minus ax, and this is exactly what we found in the beginning. Part A, problem set 2. In this question I have given 2 points, 2 vectors in the cylindrical system. So vector A is 2z minus sine phi a rho plus 4 rho plus 2 cosine phi a phi and minus 3 rho z a z, and B vector is equal to rho cosine phi a rho plus sine phi a phi plus a z. And part A says that we need to find the angle. So if this is A, this is B, I need to find this angle. And we know that this angle can be found by 2 ways, by dot product or cross product. But usually we do it in the form of dot product. So what we do is we write the dot product, which is equal to A magnitude, B magnitude, cosine of the angle. So cosine of the angle is equal to A dot B divided by A magnitude, B magnitude. So the first step is to actually find, and this we need to calculate this at the point which is given by P 160 degrees and minus 1. So first we need to find the field at this point, the vector at this point. So A is equal to 2z minus sine phi a rho. So if I put this value, this comes out to be minus 2.86 a rho plus 5 a phi and 3 az. So this is very simple. We just put the values here. For example, 3 rho z, for example this vector 3 rho z is 3 multiplied by rho, which is 1, multiplied by z, which is minus 1, and this minus 3, so it comes out to be plus 3. Similarly, B is equal to rho cosine phi, and phi here is 60 degrees, so this is 0.5, so 0.5 a rho and plus 0.866 a phi plus az, and then I can just simply calculate A dot B, which is a rho multiplied by a rho, a phi multiplied by a phi, and az multiplied by az components. And if we do that, it comes out to be 5.89. That will be just a number because it's a scalar product. Now cosine, and now A magnitude will be equal to the magnitude of this, the A vector. So that will be 2.86 square root plus 5 square plus 3 square root. So this comes out to be so I will, if I just calculate it, it comes out to be uh, so this comes out to be 6.49 and this comes out to be 1.41, and then and a dot b is 5.89. So cosine theta, I will use this rule here. So it will be a dot b, which is 5.89 divided by 6.49 multiplied by 1.41, and when I take the cosine inverse, this comes out to be in degrees, it comes out to be so cosine theta is equal to 0.6418. So this is points. So 0.6418 cosine theta. So theta is equal to 50 degrees. So I just save it, start a new one, and in the B part of this same question, I have to find a unit vector perpendicular. So I have A and B, and I want to find this vector. This is A, let's call it D equal to A cross B. So this is a unit vector, this is a vector which is perpendicular to A and B, and I need to find the unit. So I need to find DAD, which is equal to unit vector perpendicular to both A and B. And the point now is different. So A and B are same. A and B are same as previous one. So A equal to 2z minus sine phi A rho plus 4 rho plus 2 cosine phi A phi and minus 3 rho z a z. So if I evaluate, so I need to find this value at this vector at this point is P 190, 190 and 0. So it's an easy point. So the A vector at this point is equal to, so I just put these values there, and this comes out to be minus A rho, just 1, plus 4A phi and plus 0 AZ. So there is no Z component, and P is equal to 0, So it will be just a phi plus a z, and we can calculate it by using this point and these two vectors. As an example, b vector here is rho cosine phi a rho, and plus sine phi a phi plus a z plus a z. So this is my b vector, this is my a vector, and so rho cosine phi, so the point is phi is 90, so phi 90, this will be 0, so there is nothing here, and sine phi is 1, so sine phi a phi is just a phi, and az is az as it is there. So I calculate the d vector which is perpendicular to both a and b, that is a cross b, and for that I use the determinant a rho, a phi, a z, and then minus 1. So I just determinant a rho, a phi, a z, minus 1, 4, 0, 0, 1, 1, and this comes out to be equal to 4 a rho plus a phi minus a z. So this is my d vector, but I need to find the unit vector of d. So the unit vector of d, AD, will be just d vector divided by d magnitude, and if we divide this we can do it ourselves, and this comes out to be 0.94 a rho plus 0.23 a phi minus 0.23 a z. Now what is to check the answer if it is correct or not, I just find the magnitude of this. I find the magnitude of this. So if the magnitude of this, which is 0.94 square plus 0.23 square plus 0.23 square root is 1, then it means that the answer is correct. So this has to be 1. The last unit vector has to be, the magnitude has to be 1, and this confirms our answer. So we have problem number 20, in which I have two vectors, a in Cartesian 2ax plus 4ay plus 10az, and b in cylindrical minus 5a rho plus a phi minus 3az, and I need to find number a plus b at the point in Cartesian system 0, 2 and minus 5. So for this I first need to convert b into b into Cartesian from rho phi z to b of x, y and z. And this conversion, we have to look at the formula again. This conversion will need the matrix relation bx, by, bz is equal to cosine phi minus sine phi 0, sine phi cosine phi 0 and 0 0 1, and if I multiply this matrix by b rho b phi bz, I will get the bx by bz. Now x is 0, so phi is 2 tangent of 2 over 0, which is, so this implies phi is equal to 90 degrees or pi by 2. So I can easily find this. Cosine phi is 0, minus phi is 1 0, sine 90 is 1, cosine phi is 0 0 and 0 0 1. So this makes it very simple. So bx is equal to and this will be multiplied by, so this will be multiplied by b rho b phi bz. So this will be multiplied by 0 minus 1 0 1 0 0 0 0 1 multiplied by b rho is minus 5, b phi is 1 and bz is minus 3. So this is equal to, so bx will be equal to the first one, so 0 multiplied by 5 minus 1 multiplied by 1 and 0 multiplied by 3, so this will be just minus ax, or I can just write it in the beginning just because this is just magnitude, so I can just write minus 1. So bx is minus 1, by is minus 5 plus 0 plus 0, so it is equal to minus 5, and bz is actually same as bz, which is minus 3. So once I got this vector bx, by and bz, I can just calculate the sum. So a plus b will be equal to 2 minus 1, which is ax, 4 minus 5 minus ay, and 10 minus 3 plus 7 az. So this is the answer. Now B part says I need to find the angle. So as we did before with many questions, to find this angle I just need to take the cosine inverse of A dot B divided by A magnitude B magnitude, and when I do the calculation, this comes out to be equal to so this comes out to be equal to 143 degrees. So let me save this and start a new one for the C part. C part is to calculate the component of A. So the C part is I need to find a component of A. So if this is A and this is B, I need to find this, I call it AB, the component of B along A. Sorry, the component of A along B at point P. So this is, as we know, that this is the dot product. So AB is equal to just A dot B magnitude, and the direction will be the direction of B. So as we need the scalar component, so we just need the scalar vector. So that will be just A dot B, which is equal to so I have A 2AX plus 4AY plus 10AZ and dot with minus 1AX minus 5AY minus 3AZ. So that will be minus 2 minus 20 and minus 30. So that will be equal to minus 52. Part B is a vector B equal to rho square sine phi a rho plus z minus 1 cosine phi a phi and plus z square a z, and I need to find b dot ax. So the best way to do it is to first write in the form of the dot product plus z minus 1 cosine phi a phi dot ax plus z square az dot ax, and then replace a rho dot ax and a phi dot ax from the formula, and this will be 0 because they are perpendicular. So a rho dot ax is equal to cosine phi, and a phi dot ax is equal to minus sine phi, and this can be found from the formula sheet, the unit vector relations between a rho and ax, and dot that relation with ax to get these values. So now I can replace b equal to rho square sine phi, a dot ax is cosine phi plus z minus 1 cosine phi and a phi dot ax is sine phi, so minus sine phi minus sine phi. And then this is my b dot ax. Now I need to evaluate this at the point, and again this point is cylindrical, so 4 pi by 4 and minus 1, and this I can just substitute it here. So sine phi cosine phi is 1 because pi by 4 is pi by 4 is 45, so cosine phi sine phi, they will be same, and I can just put these values and find the answer.